Okay, so we were talking about one of the most important topics, that is angles. We have already discussed a few properties. Let's just quickly revise them. We'll talk about more, and then by the end of this class, we would be able to practice some more past paper questions. So let's get started. Okay. All right. So yesterday we had some discussion about some properties, and now we know what exactly vertically opposite angles are. X and Y are vertically opposite. Z and T are vertically opposite, and vertically opposite angles are equal. So what do you know? You just know that if you have two lines of this type, this angle is equal to this angle, and this angle is equal to this angle. You can have the two lines this way as well. You can have the two lines anyway, whatever way you want to. Just know that this angle is equal to this one, right? So this was the first property, and now these properties should be on your fingertips. The second property was just this, that sum of angles on a straight line is 180 degrees. So if we start off from this point, we add A, B, C, D, E. This is going to be 180 degrees. So the property was that sum of angles on a straight line is 180 degrees. Always remember this, okay? It's 180 degrees for straight line. And sum of angles in a circle is 360 degrees. So for straight line, it's 180. If this is a straight line, and if I know that this angle is 30 degrees, I can certainly say that this would then be 150 degrees, because this way or the other sum of angles on a straight line has to be 180 degrees. Similarly, if I talk about angles in a circle, that has to be 360 degrees. Then we had some discussion about triangles. So all you know so far is that sum of interior angles in case of a triangle is 180 degrees. So if you know two angles, you can easily find the third one by using this condition. That sum of angles in case of a triangle is 180 degrees, okay? Then the fifth one. The fifth one was simple. It's just coming from the previous knowledge. We know that if we look at this triangle, in order to find this angle right here, I can say that I would do 180 minus A plus B. Okay, this is 180 minus A plus B. And let's say that turns out to be C. This turns out to be C, okay? Once you have the C, you need to find this other angle, and you know that all the way from here to here, it's a straight line. So sum of angles on a straight line is 180 degrees. This would mean that this angle right here is basically going to be A plus B. Any confusions with the fifth one?
No.
Okay, perfect. So all of this was discussed yesterday. All right, okay. Let me just write it down this way. And just like I told you guys yesterday, if you were not able to understand this, it's completely fine. This is a property. You need to have this in your mind directly, okay? Then we have discussed corresponding angles. So corresponding is self-explanatory. This pink angle, like now it's blue, this angle is corresponding to this angle right here, and you know that corresponding angles are equal, okay? Similarly, this angle and these two, they are corresponding. So whenever you have two corresponding angles, they are equal. So just look at the shape, try figuring out all the corresponding angles, and then you guys would be able to know that which angle is equal to which one, okay? If I consider this shape, and if I talk about corresponding angles, so this angle right here is corresponding to this angle. Similarly, this angle right here is corresponding to this angle. Okay, so corresponding is self-explanatory. Just try following the meaning of the word and you would be able to understand it. Okay. Alternate angles. what is happening over here? So you have two parallel lines, okay? Be very, very careful. At times, students think that the two lines are careful. The examiner would give you two arrows, and or either he would specify. Only then you need to consider the two lines parallel. It could be that the lines look parallel, but they are actually not parallel, okay? So be very, very careful with that. You would get to see that thing once we talk about past paper questions. Now we have two parallel lines. They are being cut by a transversal. So this angle and this, like these two angles are alternate angles, and alternate angles are equal. Similarly, this angle and this angle, they are alternate, and alternate angles are equal. Okay, this is something that we know already. All right, okay. Then we had some discussion about interior angles when two lines are perpendicular, two lines are parallel. So think about this scenario. We have two parallel lines. They're being cut by a transversal. This angle and this angle, these are the two interior angles. Now these angles are not same. I never said that. It's just this, if this is x degrees and if this is y degrees, x plus y is basically equal to 180 degrees. Just know this, just follow this. This is what you need to understand, okay? X degrees plus y degrees is equal to 180 degrees. It's just this, that sum of two interior angles in case of two parallel lines is basically 180. Okay, this part was simple. Then we started talking about circle properties, right? So we were again talking about angles, but in case of circle. The first property and the second property in case of circle properties are very much simple. Please pay attention. You have a circle. Just know two things. The diagram could be very, very different. We don't care about that. All we care about is you need to have angle at center and you need to have angle at circumference. Okay. So this is basically the angle at circumference because this point is touching the circumference of the circle. This is the center of the circle. So this angle is basically the angle at center. The rule says angle at the center is twice the angle at circumference. Okay. So if this is 2x, this is going to be x. It could be other way around. The shapes could be very, very different. We will use this property and then you would get to understand the idea. Similarly, if you look at this shape now, what do you think? Now this is your center. This is your circumference. This is the angle at center. It's a straight line. Sum of angles on a straight line is 180 degrees. Okay. If this is 180 on the circumference, it would be half the angle at center. So it would be 90. We have used the first property and the idea is similar. The third property or the 12th property of the overall chapter was just this, that if you have two pairs of lines that are making same arc, their angle is going to be same. For example, let's consider the first two pair. Okay, so this is the starting point of first line. This is the ending point of the second line, and this arc is made by x degrees. That is fine. But if you look at this angle, again, it is starting at this point, it is ending at this point, it is making the same arc. So whenever same arc is being made, the two angles are going to be same. Similarly, if you look at it other way around, if we consider y degrees, so it's starting from here, it's ending at this point, and if we consider this angle right here, again, it's starting at this point, it's ending at this point, same arc is being made. So both the angles are same. Both the angles would be y degrees. Any confusion so far? Anything that you guys were not able to understand? All of you?
No confusions.
Okay.
No, ma'am, no confusion.
Abdullah, any confusions?
No confusion.
No, ma'am.
Okay, okay, perfect. Okay, I hope that you guys are good with this. Let me see. Okay, yes, this was the last property. Then we discussed first part of a past paper question. That is fine. Let's quickly talk about some more properties just so we can talk about some more past paper questions. Okay, Acha. For now, let me talk about the fourth circle property. That's simple. Okay. Now imagine that we have a circle. This is your circle. And I will make a tangent. Well, what exactly is tangent? Tangent is a line that is touching your circle at one point only. It can be made anywhere. For example, this is basically a tangent line, right? I was not able to make it properly, but let me try making it again. Yes, this is a tangent line. Why is it tangent? Because just know that it is touching the circle at one point only. And even if you are not able to identify it this way, the examiner is certainly going to mention that XYZ line is tangent to the circle. Okay, so I'm just explaining what exactly tangent means. Tangent is like this is also a line, but it's not tangent because it is touching the circle at 2 points. This is also a line, but it's not tangent because it is again touching the circle at 2 points. But if I talk about this line right here that is touching the circle at one point only, this is basically your tangent line, right? This is how we define tangent. It's very simple. Okay, so let me make a proper tangent line. So for instance, I am making the tangent over here. One second. Okay. Imagine that it is touching the circle at this point. Okay. Just know that. It doesn't look like, but just know it is. Okay. So we have a red circle and a pink tangent line. What exactly is the property? The property says this is the center of the circle. So if I make the radius, the angle between the radius and the tangent is going to be 90 degrees because they are perpendicular, right? Again, let's repeat the concept. Imagine this time around, I will make the tangent line over here, okay? Now this is the tangent line. Now if I make the radius, this is my radius. I can certainly make the radius this way. Again, the two lines are perpendicular. So always remember, whenever the examiner is mentioning that XYZ line is tangent to the circle, and if you see a line coming from the center, this is the radius, this is the radius, both are the radius, both are radius. This is tangent. Just know that angle between tangent and radius is always going to be 90 degrees. Again, I can make the tangent line over here as well, right? It's not necessary to have the tangent line on some specific point. And this is going to be my radius. Again, the two lines are perpendicular and the angle between them is 90 degrees. So this is your fourth property. Okay. Again, let's talk about some, and you will get to see where exactly all of this is being used. Okay, so just relax for now. Do not worry. Okay. The fifth property. Here is my circle. Now, okay. This is a point. Now I'm making these shapes one way. It could be that you've been asked some question other way around, but still the idea has to be same. Okay, so do not memorize the shape, just memorize the idea. It's the fifth property for circle theorem, for circle properties. Now I am going to make two tangent lines. I'll try making them. This is the first line. And this is the second line. Okay, now I'll tell you. The property says tangents to a circle from the same point are equal in length. This basically means this is tangent number 1. This is tangent number 2. Both the tangent lines are coming from the same point. So this length and this length, these two lengths are same. Similarly, if I consider this point, this is going to be, not this, this is going to be the first tangent line. This is going to be the second tangent line. Do not look at the appearance of the shape. Just look at the property. You have two tangents coming from the same point. So the two lengths are going to be same. Similarly, it could be that this was the point and I can have the two tangent lines this way. That's also correct. This length is going to be same. Okay. So I'll write it down. The property says tangents from the same point are same in length. So what is the fifth property? You have a circle, you have a point, you have two tangent lines. Both the tangent lines are coming from the same point. So the two lengths are going to be same. Where exactly, how exactly this would be used, we will come back to it later on. And I don't expect that all these theorems are settling in your mind very, very easily. But there should be, some part of it in your mind, just so when we talk about past paper questions, and when I get back here, you guys are able to relate to the concept. Okay. Acha. Next. Then we have the sixth property. The sixth property basically says, so we have a circle and we have a chord. This is a chord. I've told you guys what exactly chord is. Chord is just a line that is touching the circumference of the circle at 2 points, right? This is also a chord. This is also a chord. All of them are chords. Okay, but let's stick to one chord for now. And this is the center of the circle. And this is a line. Now this obviously is not radius, because radius is basically starting from center and ending at circumference. It's just ending at this chord. Okay. Now, please pay attention. This theorem has two parts. You have a circle, you have a chord, and you have a line that is being connected from center of circle to the chord. Now, if the yellow line and the red line, if the angle between them is of 90 degrees, this line is going to bisect your red line. For instance, if the red line was of 8 centimeters initially, now this part is going to be of 4 centimeters and this part is going to be of 4 centimeters. Similarly, if you guys have a circle, if you have a chord, a line that is coming from center to the chord, and if that chord is being bisected, you would know that the angle between the yellow line and the red line has to be 90 degrees. Okay, let me explain this properly. Acha. Now imagine ye meri chord. This is my chord. Okay, I can have the chord like this as well. There's no hard and fast rule. This is the line that is coming from the center to the chord, and I know that the yellow line has been bisected. Bisected means that I have divided the line into two parts. The pink line has just cut the line at exactly the midpoint of the yellow line. Okay. Acha. Now, if I know that the yellow line has been bisected, or if the chord has been bisected, I would automatically know that the angle is going to be 90 degrees. Okay. Similarly, if this is my chord, if this is my chord, and if this is the line, and I've been told that the angle between the line and the chord is 90 degrees, so I can automatically say that the chord has been bisected. Okay, so this theorem has two parts. If you know one thing, you can conclude the second thing automatically. Any confusions with this?
No confusions.
Okay, what about the other students? Please tell me quickly if you have anything that you would like to ask.
No, ma'am.
No, ma'am.
Okay.
Um,
All right, perfect. We only have 3 more theorems left. Let's talk about them quickly. Please bear with this because it's very, very important. Okay. The 7th question. Okay. So you have a circle, and then there's this triangle. And let me just make the triangle completely. So this, I have a circle and I have a triangle. Now look at the triangle first. The three sides, the three vertices of the triangle are touching the circumference of the circle, right? It is not like this, that this is my circle and this is my triangle. No, it's not like this. It's other way around. The three vertices of the triangle are touching the circumference of the circle. And you know, this angle right here is x degrees. So now if I make a tangent at this point, even this is touching the circumference. It doesn't look like, but that's because of my tablet. This is not tangent. So this is a tangent line. The property says this angle right here is also going to be x degrees. Okay, so the property says the angle between a tangent and a chord is equal to the opposite angle inscribed by the chord. Let me explain this properly. Do not worry, okay? I have a circle, I have a triangle, and I know that this angle right here is x degrees. I have made a tangent next to the opposite side, right? This is x degrees, this is the opposite side, this is the pink tangent. Now I know that the angle between the pink tangent and this yellow chord is going to be x degrees. Similarly, let's say that this angle right here was y degrees, okay? Now, where is the side opposite to this one? This is the side.
Above.
Yes, sorry, say it again.
It is above x.
This one?
Yeah.
Okay. If I make a tangent line somewhere here, I would be able to find this angle, right? So this angle is going to be y degrees, okay? Are you guys getting this? And similarly, if I know this one, if let's say if this is z degrees, I would know that if I make a tangent line over here, this angle right here is basically going to be z degrees, right? But let's just keep this to 1 because he's never ever going to give you 3 angles. He would never ever ask the question this way. This much concept is enough, okay? You have a triangle and one angle of the triangle is known, okay? Triangle stands for triangle, 3 angles, okay? One angle is known. If one angle is known, you can automatically find out this angle by focusing on the property. But this property is not very important, but still for the sake of completeness, I've mentioned that, right? So just know this, keep this in your mind. The next property is very, very important. This is basically the 8th property. And the 8th property is, so we have a circle. And we have a quadrilateral inside the circle. What is a quadrilateral? Can anyone tell me?
A four-sided shape.
Very good. Well done. It could be of any type, okay? Mine is not perfect, obviously. Okay. All right. So this is my quadrilateral. If this angle is x degrees, this is going to be 180 minus x. Why? Because if you have a circle and if you have a cyclic quadrilateral, what is a cyclic quadrilateral? Again, it is a quadrilateral who's touching the circumference from 4 points, right? A quadrilateral has 4 vertices. So all the 4 vertices must touch the circumference. Then I can say that this would be a cyclic quadrilateral. Okay, this is a cyclic quadrilateral, and the rule says that sum of opposite angles in case of a cyclic quadrilateral is equal to 180 degrees. So if you know that this angle right here is x degrees, what would be this angle? That would be 180 minus x degrees. Similarly, if I say that this angle is 70 degrees, please tell me quickly what would be this angle?
110. 70 minus 180.
Very
But,
good.
I mean,
Yes, yeah, I get your point.
180 minus.
Very good. It would be 110 degrees. Okay. So sum of opposite angles in a cyclic quadrilateral is 180 degrees. Okay, this is basically the 8th property, and that is it. This much information is fine. The next one is related to this again. Let's not talk about it. Any confusions with this?
No confusions.
No, ma'am.
Okay. What about Ariba, Rabia, and Urva? Are you guys clear with this?
Yes, ma'am, I'm clear.
Okay, very good. And Urva? Any confusions with this?
No, ma'am.
Okay, perfect. Acha. Then now we have one last property that is about triangles. Let's talk about that and then we will talk about past paper questions. Okay, so let's have some quick discussion about triangles. Okay, now triangles is a big topic. We will talk about a lot of things when we will talk about triangles, but there's just one thing I wanted to talk about. Okay, this is a triangle. Okay, this is also a triangle. And this is also a triangle. Okay, now I have 3 different type of triangles. Okay, if a triangle has 3 sides, so if all the 3 sides are same, like for this one, it is going to be an equilateral triangle. Okay, I will talk about all of this in detail in the future. I'm just explaining this verbally. Then if you have a triangle of this side where all the sides are different, all the sides are unequal, that is going to be a scalene triangle. Okay, and then we have a triangle in which 2 sides are same and the third side is of a different length. So this is an isosceles triangle. I just wanted to talk about the angle side relationship. Okay, this is very, 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 very important. Angle side relationship in case of triangles. So we have already discussed that sum of angles in case of a triangle is 180 degrees. That is already known. But if your triangle is equilateral, that would mean that this angle, and this angle are going to be equal because the 3 sides are equal. This is your angle side relationship. If sides are equal, those angles are going to be equal. Similarly, if I talk about this third triangle that is isosceles, this side and this side, the 2 sides are equal. So this would mean that this angle and this angle, these two angles would be equal, and the third angle is going to be different. Okay, and if I talk about the first one, that is the scalene triangle, where all the three sides are different, all the three angles would also be different. So this would be yellow, this would be pink, and this would be blue. Okay, so just know, whenever three sides of the triangle are same, three angles are going to be same. This means this would be x degrees, this would also be x degrees, this would also be x degrees. Can anyone find this x degrees? Sum of angles in case of a triangle is 180. So
180.
x degrees plus x degrees plus x degrees would give me 180
60
degrees.
degrees.
Very
60
good.
degrees.
Excellent. This would become 3x degrees equals 180 degrees. And in order to make x the subject, I'll take this 3 on the other side. So x would be equal to 60 degrees. So always remember, whenever your triangle is equilateral, that means whenever your triangle has three equal sides, the interior angles are going to be 60, 60, and 60. Similarly, if you have an isosceles triangle, when the two sides are same, and if you know this side right here, you can easily find out the other two sides. For example, let's say this side is 70 degrees. Okay, so I know that side is 70 degrees. This would be y degrees, and this would also be y degrees. Let's just equate this. 70 plus y is equal to, again, sum of angles in a triangle is 180 degrees. So 70 plus 2y is equal to 180.
55 degrees.
Very good. Okay, and wait one second. And then 2y is equal to 180 minus 70. Very good. 2y is equal to 110 degrees. So y is equal to 55 degrees. Excellent. Okay, so this is how we are able to relate to the sides and then find out the corresponding angles. Okay, okay, this much discussion is enough. Now let's talk about the past paper questions. Sorry. All right, okay. Okay, do not answer directly unless I ask you guys to. You can just type your answers if you are already done, okay? Because I would want all of you to think about it. Okay. The diagram shows a straight line intersecting two parallel lines, okay? Now, you need to find out the value of P and you need to find out the value of Q. Okay, that's simple. Acha. We know that this is a straight line, right? This is a straight line. So sum of angles from here to here is going to be 180 degrees. If this part is 70, what would be P? That's simple. We will do 180 degrees minus 70 degrees equals P, and that is going to be 110 degrees. So P is going to be 110 degrees. And here we have only used one logic, that sum of angles in case of a triangle is, in case of a straight line is 180 degrees. Very good, Taha and Bipesh. Your answers are correct. Well done. Okay. Acha. What about Q? Can anyone tell me what would be Q? Bipesh, your answer was correct.
70 degrees.
Very good. And how?
So first of all, we just find the angle which is opposite to P, which will be 110, and then the alternate angle to, not alternate, corresponding angle.
Okay.
That will be Q. That is going to be 110. So Q, no. Just a minute. Now it's 70.
Take your time. Yes, yes, yes. Take your time. Take your time. The corresponding angle would be this one, right? This would be the corresponding angle. That
Yes.
is 110. Very good. And then?
180 minus 110, which will be
Very
70.
good. Excellent. Well done. Okay. So this is his logic. You guys can have multiple logics, and it's just a 2-mark question. You're not supposed to write any logic. It's just this that we are discussing it over here. Acha. For the second part, you need to find out Q. Now you have multiple ways. P has turned out to be 110 degrees. If you follow his logic, this is also going to be 110 degrees because the two angles are corresponding. And if you think about this, it's a straight line. So sum of angles on a straight line is 180. So Q is going to be 70. That is fine. Let's talk about another logic or another way of doing this. This turned out to be 110. This is going to be 70 because again this is a straight line and sum of angles is 180, and if this is 70, Q and 70 are corresponding. So corresponding angles are basically equal. One last logic. We have two parallel lines. If P is 110, what would be this angle? Can anyone tell me?
70.
Very good. Because sum of interior angles in case of two parallel lines is 180. So if this is 110, the other one would be 70, and Q is alternate or vertically opposite. Q is vertically opposite to 70 degrees. That is why the two angles are same. Even I keep on forgetting these names. That's fine. Okay. You can keep the idea in your mind that if you have something of this type, this angle is equal to this one. That's perfectly fine. Okay. Well done. So I suppose that we were able to do this question easily. Okay. Acha. Some latest knowledge would be used here. Okay, let's read the question first. The diagram shows two parallel lines PAQ and SBCT. Now, he has mentioned that the two lines are parallel. So now you can think about it as two parallel lines. Otherwise, you cannot say that the two lines are parallel just because they look parallel. Okay. AB is equal to AC. Now he has mentioned that for some reason. The examiner is not going to give you extra information. Okay. So just look at ABC. ABC is a triangle and the two sides of the triangle are equal. So this would mean that this angle and this angle would be same. Okay. QAC is 43 degrees. Find the value of X. Okay. This is what we need to do. Okay. All right. I am just going to wait for 2 minutes. I would want all of you to think about it first and then we will talk about its solution. Okay. But only think about it for now. Do not tell me any answer or anything of that type. Yes, your answer is correct, Pipesh. Very good. That's right. And trust me, if he has mentioned this, this part would also be used, okay? So two parallel lines and then they're being cut by a transversal. I'm just helping you a bit, just so we are able to relate to the concept. Okay, just think about it once again, Noor, it's fine. Think about it once more. You're close. Few more seconds. Think about whatever is coming to your mind, okay? Acha, wait 1 second, 1 second. Forget about X degrees. That is irrelevant. Abhi, I don't need X degrees. Can you guys find this angle? I think this is something that all of you can do. Just find this angle. Using the idea that when you have two parallel lines, sum of their interior angles is equal to 180 degrees. Just find this maroon angle, only the maroon angle, okay? This is the question for now, the maroon angle. Okay. I've helped you as much as I can. And yes, Noor, okay. I thought you were talking about that one. Very good. Noor, your answer is correct. Taha, your answer is also correct. Okay. For the red one, that's perfectly fine. Very good. Okay. So this is what we know. Please pay attention. It's fine if you guys were not able to understand. Sum of interior angles in case of two parallel lines is 180 degrees. Well done, Moise. Okay. So 43 plus maroon is going to be 180 degrees. This means that 180 minus 43 would give you this maroon angle, that is 137 degrees. If this is 137 degrees, what would be this blue angle? What would be this angle? We know that, right? What do we know? Sum of angles in case of a straight line is 180. So 180 minus 137 is going to be 43 degrees. And even if you do not consider the parallel or interior angle logic, think about alternate angles. This 43 and this angle right here, they are alternate angles, and alternate angles are equal. So if that is 43, this is also going to be 43. Okay. So now I'm going to erase these colors. Acha. This is what I know. And since ABC is an isosceles triangle, the two lengths are same. So this angle is also going to be 43. Okay. Now what is X? Now you guys can easily find out X. Sum of angles in case of a triangle is 180 degrees. Just find out X quickly. Very good. Taha, that's correct. Yes, Nosharwan, the maroon angle was 137. Very good, Rabia. Yes, I want all of you to respond to this quickly. Very good, Moise. What would be X degrees now? Quickly. Urva, you can do it. All of you can do it, Ariba. Yes, what would be X degrees? It's 43 plus 43 plus X would be equal to 180 degrees, right? 43 plus 43 plus X degrees is equal to 180 degrees. Very good, Nosharwan. Okay. We know that sum of angles in a triangle is 180 degrees. So this ABC is a triangle. So 43 degrees plus 43 degrees plus X degrees is equal to 180. 43 plus 43, you need to add this thing. And this is going to give you X degrees equals 180 minus 86. And this is going to be 94 degrees. So this was 94 degrees. Okay. And this was just a 2-mark question. So you guys need to be quick at it. And you would get quick, inshallah, once you get to practice good number of questions. So it is 94 degrees. Very good. Well done. Excellent. Okay. Let's talk about the next one. Let's talk about the 5th question. 1 second.